On Wednesday, August 12th, 2026, the moon's shadow will touch the Earth in the Arctic Ocean and race southwest across the top of the world. It will cross northern Russia. It will sweep over eastern Greenland. It will pass over Iceland. It will run down the length of the North Atlantic. And then, as the sun sinks toward the horizon, it will come ashore in northern Spain, bringing total solar eclipse to mainland Europe for the first time since August 1999. Then, that same night, once the shadow has moved on and the sky goes dark, the Perseid meteor shower reaches its peak, under a new moon, which means the darkest skies possible. Two of the best events in astronomy on the same date, roughly 12 hours apart. That is not something that gets arranged. It's a coincidence of orbital mechanics, and it will not repeat in most of our lifetimes. Here's exactly what will happen, where, and when. Start with the eclipse and start with why they're rare. The moon orbits Earth roughly every 29.5 days, so it passes between us and the sun about once a month, but its orbit is tilted a little over 5 degrees relative to Earth's orbital plane. Most months, the new moon's shadow passes above or below us entirely and nothing happens. Only when a new moon occurs near one of the 2 points where those planes intersect does the shadow actually land. And there's a second condition. The moon's distance from Earth varies. When it's farther out, its disk appears too small to cover the sun completely, and you get an annular eclipse, a ring of light. Totality requires the moon to be close enough that its apparent size exceeds the sun's. Both conditions are met on August 12th. The moon's dark inner shadow, the umbra, will reach the ground. The shadow's journey begins over the Arctic. It touches northern Russia, then moves across eastern Greenland, a place with almost no one to see it, before reaching Iceland, the first substantially populated land in its path. The point of greatest eclipse, where the shadow is centered and totality lasts longest, falls in the sea about 45 kilometers, 28 miles, off Iceland's western coast, at roughly 65 degrees, 10 minutes north, 25 degrees, 12 minutes west. Maximum duration of totality there is about 2 minutes and 18 seconds. 2 minutes 18. That's the ceiling for this eclipse. It's short by historical standards. Some eclipses run past 7 minutes. But every person who has stood in a total eclipse will tell you the same thing about the duration. It doesn't matter. For Iceland, the eclipse begins around 4:42 p.m. GMT and finishes near 6:49 p.m. Reykjavik and Keflavik are in the path, along with Borgarnes and Ísafjörður in the west. Then the shadow crosses the open Atlantic and reaches Spain. Spanish totality is, in my view, the most interesting part of this entire event because of the timing. Across northern Spain, the eclipse plays out in the evening, running roughly from 7:30 to 8:46 p.m. Central European summertime. The sun will be low. In parts of the path, totality occurs with the sun only a handful of degrees above the horizon. Think about what that means visually. A normal total eclipse gives you a black disk high in a blue sky. A low sun eclipse gives you the eclipsed sun sitting just above the landscape, with the corona flaring out over mountains or ocean, and the moon's shadow visibly rushing toward you across the terrain rather than descending from overhead. Photographers have been planning for this specific geometry for years, because it lets you put the corona and horizon in the same frame, something almost impossible at midday. The Spanish path is broad and includes real cities, Gijón and Oviedo on the Asturian coast, Santander, Bilbao, A Coruña and Lugo in Galicia, Vitoria-Gasteiz, Logroño, Burgos, Palencia, Valladolid, Segovia, Zaragoza, Teruel, Valencia, and out into the Balearics, Palma, Ibiza, and Mahon on Menorca. A small northeastern corner of Portugal also falls inside totality. Madrid, notably, does not. The capital sits just outside and will see a deep partial eclipse only, which is a completely different experience, and I'll explain why in a moment. Now, the weather, since that's the variable nobody controls. Climatologically, average August cloud cover across the Spanish path runs under 50% and near 35% along much of the central track. The most favorable statistics are found inland over the Ebro River floodplain around Huesca and Zaragoza, where August cloud is genuinely scarce. The Atlantic-facing northern coast, Asturias, Cantabria, the Basque coast, is more prone to marine cloud, but there's a catch specific to summer in Spain. Afternoon and evening thunderstorms are common in August, particularly over higher terrain. Since totality falls in the evening, storm timing matters more here than it would for a midday eclipse. The practical advice from experienced eclipse chasers is universal. Stay mobile, watch the satellite imagery on the morning of, and be willing to drive. Outside the narrow path of totality, an enormous area gets a partial eclipse. Europe, Northern Asia, North and West Africa, much of North America, and stretches of the Pacific, Atlantic, and Arctic. In the United States, a partial eclipse is visible from Alaska to North Carolina, though the moon takes only a small bite out of the sun, and the coverage varies considerably by location. Here's the thing I want to be clear about, because it disappoints people every time. A 90% partial eclipse is not 90% of a total eclipse. It is not even close. The sun is roughly 400,000 times brighter than the full moon. Leave 1% of it uncovered and the sky stays blue, the corona stays invisible, and the temperature barely shifts. Totality is not a matter of degree, it's a threshold. Cross it, and the sky goes deep twilight, planets and bright stars appear, the temperature drops noticeably, birds go quiet, and the sun's outer atmosphere, the corona, becomes visible as a pearl-white halo that no photograph has ever adequately captured. That's why people fly across oceans for 2 minutes. Now, safety, and this is non-negotiable. Anytime any part of the sun's bright disk is visible, you need certified eclipse glasses or a proper solar viewer. Ordinary sunglasses are not adequate, not stacked, not the darkest pair you own. And never look through binoculars, a telescope, or a camera without a solar filter fitted to the front of the optics. Those instruments concentrate sunlight. Eclipse glasses held behind a telescope eyepiece will fail within seconds, and the retina has no pain receptors, so damage occurs without any warning sensation. The only exception is during totality itself, and only within the path. When the sun's disk is 100% covered, it is safe and necessary to look with unaided eyes. The moment any sliver of the bright disk returns, filters go back on immediately. If you're in a partial eclipse region, there is no safe moment at all. Then comes the night, and the second half of this remarkable date. The Perseid meteor shower is active from mid-July through late August, and in 2026 it peaks on the night of August 12th into the early hours of the 13th, with the predicted maximum around 1453 UTCs on the 13th, meaning the mornings of both the 12th and 13th are strong bets, and the moon is new on August 12th. That's the crucial detail. Moonlight is the single biggest natural obstacle to meteor watching, and this year there is none. Under a genuinely dark sky, the Perseids can deliver dozens of meteors per hour. The physics is worth appreciating. Comet Swift-Tuttle, a body about 16 miles across, has been shedding dust along its orbit for thousands of years. Earth passes through that debris stream every August. The particles are mostly sand-grained to pebble-sized, and they enter our atmosphere at extraordinary speed, compressing and heating the air in front of them until they vaporize. Each streak of light is a fragment of comet, older than our species, being destroyed roughly 50 miles overhead. To watch, go out once it's fully dark, look toward the northeast for the constellation Perseus to clear the horizon, and then let your eyes wander. The meteors radiate from that direction, but can appear anywhere in the sky. Find an open spot, away from streetlights, get comfortable lying back, and give your eyes a full 30 minutes to dark adapt. Checking your phone resets that adaptation instantly. August 12th isn't the end of the month's calendar either. From the 14th to the 16th, Venus reaches greatest eastern elongation, its widest apparent separation from the sun in the evening sky. Look low in the west shortly after sunset for the brightest object there. Through a telescope, it will appear roughly half-lit, showing phases exactly as Galileo first described in 1610. And on the night of August 27th, running into the 28th for some time zones, the full moon passes through Earth's shadow in a deep partial lunar eclipse, visible from much of North and South America and parts of Europe and Africa. At maximum, about 93% of the moon's diameter sits inside the umbra, the dark central shadow. It won't be a full total eclipse, but at that depth, the moon can look dramatically darkened with a rusty, coppery tint along the covered edge. Lunar eclipses require no eye protection whatsoever. If you can't reach Iceland or Spain, several observatories and organizations will be streaming totality live. And if you miss it entirely, there's a consolation that eclipse chasers are already circling. August 2nd, 2027. That one crosses southern Spain, North Africa, and Egypt, and totality along its center line runs over 6 minutes, one of the longest of the century. But August 12th, 2026, is the one that ends a 27-year wait for mainland Europe. 2 minutes and 18 seconds at most. A sun sitting low over Spanish hills with its corona burning around it. And then, hours later, the debris of a comet burning up over a moonless sky. Set an alarm, clear your calendar. This is the best day of the astronomical year.